Okay, welcome back. Let's have a look at the main page of the repository. So go to the Game 2004 repository. In the description, as some of you have already found, I've added the final project brief. So yeah, it is time to start thinking about the main objective for this class, which is to create a small game level using and showcasing the techniques that you've learned and using some of the code that we've been working with. So yes, I understand some of the procedural building techniques that I've introduced maybe are a little bit more complex than what you work with up to now. But this should pay off because they allow you for a lot of easy to achieve variations and kind of a creative coding aspect. So you saw that in the lab test problem 2, that it was relatively easy to change it to create something which is interesting shape in itself by just changing a couple of variables. So well, you definitely need to be on top of what's happening there in that code. I'll expect you to create your own scripts which generate different types of buildings. You can maybe use simpler ones, you don't have to necessarily use recursion. Okay, so the main idea is to create this small game level which is based on the procedural city. You can take it in any direction that you like, so you can experiment with different types of buildings, different structures. I do want there to be like a creative element to it, so later on today I will get to maybe some easier to use tools which you can use to play around with different ideas and then implement them in Unity. So basically whatever your strengths are, whether it's art, coding or design, I want you to apply them to this small little project and modify it and add different layers. We have been talking about physics. I will still talk about animations and game AI. So I would like these elements to be incorporated in your game level. Now, it doesn't have to be a very complex game in itself. Simple behaviors and simple gameplay ideas are fine, but use your imagination and use the blocks that you have at your disposal to build something new. So feel free to add extra assets from the asset store or maybe assets that you created yourself if you have some 3D modeling experience. At the same time, I do want you to use the basic building blocks that we've been working with. So this should be the basis of the game world, but you can add other elements to put it in the context of, let's say, a space station or whatever else you feel compelled to do. So yeah, this is quite a lengthy write-up there I gave you in this PDF. Well, this is just to kind of make it as clear as possible to what I'm expecting. So the genre itself, don't worry too much about it. Play around with the ideas until April 22nd, and think of what you'd like to be developing in the future in your career. So this is an opportunity for you to maybe self-study in areas that are more interesting to you. So if again, like if you're interested more in creating narrative experiences, then by all means make it into a mini exploration adventure quest. How would you do that? Like, that's just a simple example. We know already something about collider triggers, so we know how to trigger a certain code when the player enters a certain area. That's already a starting point for like an adventure quest. So you can set up your city first. This is your starting point. This should be also quite a big chunk of your work on this project is creating a more complex, more interesting city based on the code that I've given you already. So feel free to make the city larger, or feel free to change the scales, vary the procedural generation methods, get creative with it, basically. So once you have your city built, work on some of the skills that you've learned in previous Game Tools semester. So work with different assets, work with materials, add a layer of sound to it. I will be providing you extra tools along the way for that as well. I've already done a very small example of the audio handling in the last week's lecture. And also, if you have some specific interest in doing something that you find interesting, by April 22nd, let me know, message me, and we can talk about those ideas and how feasible they are in the time frame that you have for it. So remember that you do have a deadline, and maybe you might still be limited in the means you have to implement the idea, but this is where it's important to get creative, and game development is going to be about solving problems and improvising. So this is your battleground, and use what you've got to your advantage, and in the end make sure that the final result is complete, so that it actually fills the specs that I've given you, which is use the procedural generation, spend a little bit of time on playing with those methods to create something new. Use some assets to make it not just this generic blocky thing. Maybe you can find ways to make it more interesting. Vary the widths and heights of each layer of the city, for example. Add different decorations. At this stage, if you have a good handle on the code that we've been working with, you should be able to extend it. You should have everything that you need to take it in different directions. I will be talking more about animations next week, so this would be a good time to talk about maybe doing something like a mini cutscene. We can animate the camera track and make a little mini movie out of the environment that you have. Additionally, you will be placing characters. We've already worked with the player rig and the player controller. We've also created an animated character turret which reacts to the player and does something. So these ideas and this type of code can be extended to create maybe hostile characters, or large numbers of cars floating in the futuristic city, things along those lines. So start with what you've got. See what blocks and techniques you have at your disposal. See what your other skills that you may have learned on your own on previous classes, and how you can bring them to the table. And by April 22nd, let me know what you'd like to create, and by that time I need the link to a Git repository. So create a separate Git repo just for the final project. This is what you'll be working with, and I would expect you to use a Git client for this. So let's say probably 50% of you are already up to speed with how to fork, clone a repo, and commit to it. Some of you don't, so there's plenty of materials if you get stuck with SourceTree or Git Desktop. If you need help really badly, also let me know and I'll try to sort your particular problem there. But Git is your basic developer's tool, so it is important that you use it. So I was lenient this first lab test and let you submit by email, but final project needs to be done by Git. And additionally, you need to commit your work regularly. So as you add things to the project and work on the code, I expect you to commit it. By the end of the project, which is a submission on May 20th, I would have a look into the history of your work on it. So regular work is definitely advised, and it will help you pace yourself and make sure you don't run into problems last minute, which seems to be the name of the game. And lots of game development scenarios, there's always not enough time, and the final time before delivery is always a very much of a deadline, crunch time, and people staying in late to make sure that everything is working. So quite stressful. The way to avoid this obviously is to kind of start early, have a good plan. Let me know if you have some problems. Discuss your idea with me, so perhaps I can help you avoid some problems. Again, so I mentioned some possible ideas. So mini adventure. So all that needs to happen is, okay, we have an interesting looking city, we have a player character that can move around it. Perhaps you can use some animations for that. And some active zones which will trigger, let's say, overlay or a sound which tells you what to do. So we're talking about this kind of level. Obviously you can take it if your ability and ambition is larger than that. Obviously show me what you got there. So 40% of the final submission score is going to be for completeness, 20% for complexity and ambition. So obviously I wouldn't be very happy if you just give me back the code that I made for you to begin with as a template. Visual audio, 20%, so make sure that this is visually appealing, interesting. Add audio or other elements that will make it a more immersive environment. You've been picking up lots of skills along the way. Now put them to use here. And originality, fun. Yes, there is fun is definitely a factor. I don't expect this to be like a super involved game, but we'll try to make it at least worthwhile spending a couple of minutes in and memorable. So this is the basic outline. Let me know if you have any questions about it. Maybe this would be a good time to ask as well. This is individual project, so you work on your own. I'd say, yeah. I will. Okay. I decided. Okay, I was going to give this to you at the end of the lecture today, but I decided just to maybe stress you first and then go into more fun bits. Because I do realize that a large part of the class is still having some problems with this, maybe the complexity of the level we've been working on. So we're gonna try to make things a bit more simpler and fun for you to work with, but you definitely will have to put in quite a lot of work. Nobody said it's going to be easy. Game development is complex and programming is hard. So I'm here to try to help as much as possible. But you will have to put in the hours. Okay. But the main thing is, if you put in the time and if you take some time to experiment and play around with the code, I can guarantee you that it shouldn't be too hard to make something. Now, whether it's gonna be a good game, that's another thing. But I appreciate the effort, I also realize you have kind of different starting points in your programming ability. I will try to take that into account as well. So, what is important that I see that you commit regularly and that you work on your project. And in the initial submission, I need to see that you have thought this through. So you have some time over the spring break time as well to maybe be a little bit stressed about other things. Use the time as well to maybe come up with some sketches, storyboards. I don't need anything very very advanced or complex, but I'd like you to try to create something which is game-like. If you're more interested in the kind of experiential type games, walking simulators and maybe VR experiences, you can push the things in that direction as well. But I still would like to see physics, the physics engine being used, and game logic. So it cannot be just a entirely non-interactive scene. I would like to have a little bit of player input there. So if it's more movie-like, make sure that there's complexity to the actual scene. So, for example, there might be objects in the game world which react to each other, and we are viewing that. So that's a possibility. You can push that in that direction. I'm super open to your own individual ideas. Yes, you can make a game about Corona. I don't have a problem with that. I can even point you out to some particle effects or GPU particles. So this is kind of one of the areas where kind of my interests lie. Okay, so again, number one for the time being is make sure you're on board with your Git client. Yes, you can use VFX if you already have some experience. I can do a little mini session during one of the lectures about VFX as well, if there's interest. Any other questions? Yeah, let's get it. Let's air. No. Just
like you have the 2004 and 2004, 20, whatever files or whatever that we use, and so we have to make that 2 files.
No, this was okay. This was you basically cloning or forking existing repository. What I'll need you to do now for this is create a new repository of your own. So you can create a new repository on GitHub just via the GitHub webpage. So perhaps next class I can give you a quick walkthrough, but start looking into that. Yeah, I'll spend a little bit of time next week about setting up a new repository of your own. So make sure that your SourceTree client or GitHub desktop works okay with the existing repositories, and practice creating a new repository. If you have trouble, I'll briefly cover it next week. Now, we can't spend too much time on this at this stage because we still have a lot of material that I think animations would be quite important, and also a little bit of game AI, so that you can have enough building blocks to create something interesting. I think by now you should have enough of a system available to to create interesting, a city which is interesting visually. Problem 2 was a kind of like an example of taking it in that direction. But obviously you will have to write your own code, maybe to an extent that the lab test wasn't testing. That's why I have a couple of suggestions now for you. So let me actually do something different, and I'm gonna play a little video for you. This is a slightly surprising tangent maybe for you, but I'm gonna talk about, we're gonna actually listen about tennis. And there's a book from like sometime around 80s, I think, The Inner Game of Tennis. And there was this guy, Tim Galloway, I believe, who claimed that anybody can learn to play tennis in an afternoon as long as they don't try too hard. So seems a little bit like a departure from what we're talking about so far, but by the end of the class I think you'll see that learning to play tennis and learning to code is in some ways similar, and it's important not to get into one's own way in doing that. So let me cue up the little bit of a talk by Alan Kay. I don't know if you've heard that. Anybody heard of Alan Kay? Well, it kind of should. I mean, he's American computer scientist, and he was behind lots of inventions and developments that kind of like are very commonplace and you're using every day. So he was involved with Xerox Palo Alto, where the first user interfaces, graphical user interfaces were developed, and things like say the mouse. Additionally, later on in his career, he was the chief scientist for Atari, for example. So that's maybe more of a street cred for that guy. So without much further ado, I apologize for the quality of the video and the sound. Unfortunately, this is the best version of the talk I was able to find on YouTube. This is quite an old thing from the archives. And if the sound isn't sufficient, actually let me just change my sound setting. I have a little bit of problem with my Discord where I cannot actually stream the sound from the screen share. Yeah. Yeah. So there is a link. Let me actually send this to you. It is fixable, but in this case, on my present kind of gaming laptop, I would have to actually reinstall Windows to get the latest update for Windows 10, because at some stage I just I disabled the newfound boot partition setup. I went with Legacy so that I can have a multi-boot, and this is something Windows doesn't like, and it won't let me kind of get to the currently supported version of Windows 10. But okay, this is beside the point. So I'm gonna send the link now on the channel. So this should start you out exactly at the moment that he's talking about tennis. So. Let me set up. Hold on a second. Okay, I'm sorry. I'm gonna have to. Sorry, what did you say? If you click that link, it starts at 00. Yeah, it's 56 minutes 20 seconds. But if you click the link itself, it should take you to the right timestamp. Anybody else having a problem with this? I'm gonna set it up so that you should be able to hear something. I just need to lose my headphones for a second. Okay, well, let me just yeah, I know it should work, but actually what happens in my case is Discord is giving me a problem, and I would have to, so technically yes, it should work on paper, but it doesn't for me. The recording should be okay though, so what he's going to talk about is this guy who heard this claim by Tim Galloway about being able to teach someone to play tennis in an afternoon, and he kind of thought, oh, this is like a right charlatan, so let's expose him. So he actually created a TV program, and well, Alan Kay is going to talk all about it, but give me just a second with the sound. So you should be able, if you have for some reason a problem of playing it, it should be able to.
Notion that there are, each one of these things evolved for a different reason and can do different kinds of logics is very important.
Okay.
You see, and he had read a book that apparently upset him called The Inner Game of Tennis, which basically said almost anybody can learn to play a decent game of tennis in just a single afternoon if you don't try too hard. And that had made him wonder, because he'd been trying to play tennis for many years, and so he sent an ABC news squad out to California to expose the charlatan. And what they did was to round up a number of people and get them to sign legal affidavits saying that they had never played tennis before. They took them all out in the court and picked the worst one, who happened to be a 55-year-old lady, 40 pounds overweight, 5'2", and a muumuu. And she had the muumuu because her deposition said that not only had she never played tennis, but she'd not even exercised in 20 years. So taking them all in the court, turning on the live TV cameras, they set a clock and said to Tim Galloway, you have 20 minutes to teach her how to play tennis. Now let's look at this from the standpoint of user interface design. Because in every way, Tim Galloway is the user interface of this interactive teaching situation we have, and let's see what he actually does.
I'm going to have Tim hit the
This
ball,
has sound.
and as the ball flies through the air, I want you just to watch it. In the very instant the ball hits the court, I want you to say bounce. In the very instant the ball hits the racket, I want you to say hit. So you just be saying bounce, hit. All you need to do is watch the ball. Okay? The key of all the exercises in the inner game is to focus the mind's attention somewhere where it will not interfere with the body's ability to hit the ball automatically. You stand here and Tim will throw you a couple, and you just continue doing the same thing.
Should I try to hit it?
Not at first. At first, just say bounce when the ball bounces and hit when you would hit it, but don't hit it. Then after you feel like hitting it, go ahead and hit it.
Okay. Now you might watch your right arm here. Hit. Something's trying to hit that ball, even though she was told that she didn't have to. Now she actually tries, she misses.
also out of the corner of his eye
Yeah.
watching me hit the ball. So even though he's not trying to see how I hit it, the image of me hitting it is going right into his memory. You enjoying yourself?
Yeah, it's really fun.
You like that? Okay, there you go.
Love it.
The cardinal principle in any book written on tennis, about tennis, is to watch the ball. No tennis player really sees the ball enough. And the reason is they get bored. So I try to give them something to see in the ball that's interesting. So we watch the trajectory of the ball, the gracefulness of the line made by the ball that flies through the air. Always it's the same. Put the mind somewhere where it can stay calm and not get you uptight, but relaxed and interested. Then the body does so beautifully, so beautifully. I might start listening to the ball, Molly. Listen to how it sounds in your racket. Hear that?
Yes.
Hear that one? What did that sound like?
Very dull.
It was like wood. The wood sound. Keep listening and you'll hear the sound that you like pretty soon. Just listen to it. Okay, now listen on this side. Have a drill. Okay. Now be aware that racket is part of your arm. That's it. Just feel it. Don't try so hard. Let it happen. That's it. Do what's comfortable, Molly.
Every time I did start to think, things went wrong. When you just stop thinking, the body seems to know what to do.
Can you feel with your left hand where it is? There you go. Just in the back there. Feel it. Okay. Now, I'll tell you what, Molly. We're going to do one other stroke now. And this one's called the serve. And the serve is just like a dance. It's just like a dance. We'll come back here and I'll show you how to do a dance called the serve. Okay? And I've done this dance a little bit, so I'll just do it. Okay. Da-da. In fact, you can start humming if you want. The rhythm, like this. Like this. Da-da-da. Da-da. Out loud. Okay, now, then what you do, I want you to stand there, shut your eyes, and imagine yourself doing that same dance. You might start humming a little bit. As you're doing it, yeah. Okay, now what I want you to do is no thinking, just go do it, quick. Just no thinking, just go serve, yeah. Serve, fine, don't worry about missing. Keep serving. Don't think. Go, do quick. That's it. Down. Fine. Again, don't worry about hitting that. Down. Out loud. Let's hear it. Out loud. The rhythm. Down. There you go. I get them to hum the rhythm of my serve. So they're not thinking, oh, this is what he's doing with his elbow. This is what he's doing with his hands. Out loud. The rhythm. Down. There you go. I get them to hum the rhythm of my serve. So they're not thinking, oh, this is what he's doing with his elbow, this is what he's doing with his hands. They're not trying to remember all that. They start humming. And they see themselves doing very similar things, muscular movements, to what I did. But they're not thinking about it, so it just comes out naturally and fluidly. That didn't take long. That's called serving. Out. Out. Don't miss it. Good. Come. Okay? Okay, that's your first point in tennis. Score is 15 love.
Fantastic.
Okay, Molly. No need for you to miss.
All of a sudden, everything became effortless. I was just sort of like floating along, and doing what came naturally, and I said, I'm playing tennis. It's really beautiful.
Have a clear idea of what you want, then let it happen. Don't try too hard. I'm going to try to make you miss, Molly, because it's going on too long. So I'll just get a little bit harder. You just keep watching the ball. Keep watching it. They're rooting for you, Mom. Don't be distracted. Keep on that ball. Oh, that's fine. That's called tennis.
Well, when I saw that, I said something akin to holy cow. So I'd just seen something that I wouldn't have believed possible, and I realized that it applied very strongly to user interface design, that something really important was going on here. So I got Tim Gallway's book, The Inner Game of Tennis, and I read it, and a number of things that he said really stuck in my mind. First one was almost a cliche. He said, learning happens when attention is focused. But he was able to get something out of that, because if you don't have a good theory of learning, then you can still get it to happen by just helping the person focus. One of the ways you can help a person focus is by removing interference. And a lot of what you saw in that tape was a way of holding focus of the mentality that actually had to learn to play the tennis and removing interference from the mentality that likes to talk and make comments. Another thing that Tim said that's particularly stuck in my mind was, he said the problem with most theories of teaching is that the parts of the body you want to have learned don't understand English. So the part of your mentality that understands English doesn't play tennis, can't play tennis, can't do mathematics, it can't do music. What it can do is talk and comment. And so in general, for learning most things, it is good to find a way of short-circuiting that mentality that we think of as the I that always tries to take over. And finally, Tim made a very interesting observation, and that is that the problem with being a beginner is that you get a lot of practice in staying a beginner. So a beginning tennis player, most of the time, does chase the ball. They get to be really good at chasing the ball, but all other forms of tennis involve hitting the ball. So it's very important for Tim to find a way of catapulting anybody learning tennis, like Molly there, out of the chase a ball stage and instantly getting her to hitting the ball stage. So he had to find a way of getting a person who had never picked up a tennis racket before to be able to hit the ball 98% of the time they swung at it. We realized that was an incredibly important principle for user interface design. Why spend 2 weeks trying to read an MS-DOS manual to see how to copy a file or open up an application? Why do any of those things? What is it? What do you get from it? Much better to find a way of designing the user interface so that the person who uses it acts like an intermediate from the first time that they sit down. And then they get into a process that is rewarding in itself.
Okay, so this was the first part of the Alan Kay lecture that I wanted to share with you. There's a link for the entire talk. It's really very worthwhile. If you are interested, I'll let you unpack the meaning of it kind of on your own afterwards, after you see the second part. So I'm not going to spend too much time on this, but the important thing, one of the important things that Alan was saying is, the different mentalities or parts of your mind that are involved in solving a problem or learning something. So the main thing in the tennis example was that teaching tennis by describing teaching tennis by using English language is all good and fine, but it's not the part of the brain that is involved in that in playing tennis. Your muscles and your coordination doesn't speak English, so it's somewhat of a different mentality that's involved in the problem. So computer programming is kind of on the other side of this spectrum, so it's all very symbolic oriented and complex, and it's all symbols and text and language, but there is other ways to learn those concepts, and another important thing there was to be relaxed and not get your kind of emotions or frustrations to get in the way of solving a problem. So one way of doing that is by playing. So I was I did have some questions from some students about games which would help you to learn to code. I went on Steam and I did a little bit of a review of what's out there, and I have to say I didn't find anything that would be all that useful for teaching object-oriented programming languages like C#. Specifically, I did find a couple of games that are somewhat relevant. So there's one called Botland. There's something called Robo Instructors, Robo Snakes. They're all fairly simple games. Feel free to try a demo version or have a look at them. But quite honestly, I don't think they would help you that much. There's a very nice series of games by a developer called Zachtronics. They are mostly geared toward more assembly language style skills, so they're a little bit more maybe interested to hackers and I don't know, Arduino builders, people who are more interested in hardware, not necessarily game developers who need to create work with scene managers and object-oriented structures. But these are interesting games. One game that I remember from many years ago. I didn't play it a lot, but I remember checking it out and thinking, okay, this is quite an interesting concept. It was a game called Colobot. So it is quite ancient, but maybe these days it's not such a bad thing. There's big interest in retro, so definitely goes into the that kind of bracket of if you would be somebody who's happy to play the first Half-Life, then maybe this won't put you off too much. But what this game does is actually teach you. Let me check if. Okay. It teaches you a C-like programming language called Cbot. Additionally, this game is open source, so you can actually check out the whole code and have a look at it. This is not based on Unity, this is a custom engine. Let me fire it up really quickly and just give you a quick rundown. Okay, I'll disable the sound because I don't have a... Okay. So this game is... Okay, admittedly, it's all looking pretty primitive by today's terms, but there is an interesting core to the game, which is you're exploring a... Okay, so in this game you interact with machinery and bots, which you can control to terraform alien planets and fight off aliens. It's all very simple. Maybe it reminds you of concepts like Lego Mindstorm or whatever. But the interesting part is that you can actually program those bots and have them do things automatically using something which is quite similar to C#. Let me see what's happening there. Is this gonna run okay? So for example, this is a sample of an example of a bit of code which swaps the battery. So I'm placing the bot in front of a battery and I'm running the switch cell program. And this is what happens. So factory swapped. A very simple bit of code. It's pseudocode, so it has some instructions which don't exist in, say, C++ or C#, just to do things which are specific to the game. With any kind of game that teaches programming, like, you kind of have those pseudo structures. So there's quite a lengthy tutorial sequence of tutorial levels, which are, some of them are quite boring and involve a lot of fetching and running around. So just to save you some trouble, if you want to check this one out, I zipped up a couple of saves, and you have a link to them in the presentation. There's a Discord server for it as well. There's a little bit of a community still alive after so many years. I could just find a bit more interesting problem there. This is not to save there. So this is a program that should... Okay, I think I broke this. So we can see a very simple declaration of a couple of variables. So there's a start variable which holds the initial position. There's a item variable which basically will hold the position of the power station. In the first line of the program, you store the position of the object into a variable. So that we have a reference point later on when we want to come back to the place we started from. Then in the next step, we use our radar, so we run the radar function with the argument power station. So this will look for the power station and go to that position. Let me just see, is there a power station in this level at all? That's not the right level, sorry. Okay, so let's say I run the recharge program, and what that does is now, okay, that position of the charging station was obtained, and then go to instruction with that result was executed. So then the droid flies to the power station and then runs a while loop. While the energy is less than 1, it just waits, and this results in the batteries being recharged. That all gets a little bit more complex once you get different types of bots. Like this is a bot that can shoot bullets. Okay, I'm just gonna quit this now. There's also an interesting section of the game which is called code battles. So in this you can run a code battle versus other players, so you can both create code that is being run on this on your droids and then test them against each other. So that's a kind of a way to have a bit of a challenging take on the learning to code. So again, like it's a pretty old game, but I think this is kind of closest to getting a somewhat of a resource management survival game, which actually has to do with programming. Okay, continue. Pressing F1 takes you to your SATCOM, which also has a description of the programming language involved. So a lot of the keywords that we're learning about for C#, while, for, do, switch, if, else would be available here. They're very similar, so even though this is not exactly identical, it is possible to play with this and actually learn something while playing the game. So okay, well, it really depends on your tolerance for retro. So if you're the type that enjoys Minecraft, for example, then perhaps you would get something out of this one. But let's move on now to another one, which is Blockly Games. Now this might look a little bit, like beginners programming for kiddies. However, this might be only like a surface impression, because there's actually lots of good learning to be had from this. Let's see how this works. Like, open that link in your browser. This all works in the browser. You can also download an offline version, and let's have a quick go at like the first puzzle. So this shows you how these blocks are. Here you're working with a visual programming paradigm. So instead of writing text, you're connecting blocks together. So bear with me for a moment. This is just to test whether you know how to connect, use the puzzle blocks together. So for example, cat, we need to connect the right connection there. Legs, okay, we choose cat has 4 legs. Yeah, traits, it has whiskers. So this is how those components snap together. This is done using Google's Blockly interface. So this is how those sprites work. A couple of other games and projects use this as well. We'll get to that. Okay, what else? Fur. Okay. And so on. Yeah, and well, I'm not going to complete this as all. It's a little bit trivial, but this is how this works. And then the second puzzle. Okay, I think I have to actually. Okay, let's go to say maze. So in this case, in case of maze, we need to kind of use the right commands to get to the target. So okay, so move forward. Yeah. Okay, bingo! Very trivial, but later on things get a little bit more interesting. So now we have move forward, then turn left, then move forward, then turn right, then move forwards. Yeah, exactly. It is a kind of a variation of Scratch. So I don't know. Some of you might be familiar with either Scratch or Squeak. Also, that's actually interesting because Scratch is based on Squeak. Was built with Squeak, and Squeak actually derives from a project called Smalltalk, which is something that kind of goes through the whole history of object-oriented programming, and Alan Kay comes back here because he's one of the developers for it. Actually, yeah, Squeak was also developed by Alan Kay, so this is all very interrelated there. So yeah, this is still very simple and probably not that useful, but you know, feel free to like quickly race through this at your own pace later on. What I'd like to get to is an interesting section here, which is the turtle. So anybody heard of turtle graphics? So you know, a long time ago, when let's say the home computer standard was something like the ZX Spectrum, you know, kids would play with learning basic programming using this thing called Logo, which is again like a kind of a more visually oriented language. The way it works is like you have your turtle and you issue a command to it. So in this case, we want to create a we want to plot a square on the screen. So to do that, we need to set up a simple loop. Okay, so this is a loop, repeat 4 times, that's fine. So what do we need to do? Move forward by 100, okay. And then another command is turn right by 90, and that actually should do it if these distances are okay. Okay, so that's our square. Yeah, I'm ready for level 2, and in this case, okay, it gets progressively more difficult. Here the slider lets you speed up the execution. So in this case, I mean, clearly we need to change the angle that we rotate and also the number of iterations. So let's go for, in this case, it's going to be not 90, it's going to be 120 or 144, 5 times. What do you think? What's the number? Okay, that's, haha. That's the wrong star. Okay. Okay, so we've got our pentagram and so on. Okay, and it all kind of gets progressively more complex. In this case, for example, like we move the pen up. So let's do it really quickly. I'm just gonna not spend too much time on this. So again, we need to repeat this 4 times. Move forward, turn right. You might have this initial reaction that, hey, what is this? Is this for kindergarten? Well, yes and no, but coming back to this idea of solving problems with the right mentality, you know, programming, yes, it's symbolic, and yes, it's complex, and yes, it involves language. But also, to a certain degree, it is visual. So actually, visual programming language are good, like first, you know, first contact, or maybe like an accessible way to learn about more complex ideas, like you know, functions, methods, arguments, return variables, which I'll demonstrate really quickly. What was that? 120. That's fine, and then we need to lift the pen up, go forward, I think probably a further distance, then pen down. Okay, we need to modify this to pen down, okay, and again move forward. I think this is going to be a short distance, only 20, I don't know, let's see what we get at the end of this. Okay, this is too large, so clearly we need to decrease that. Okay, wrong angle. I'm not doing very well at this at all. 144. Okay, so that's that solved. And then we can do something a bit more interesting, like adding a nested loop to the whole thing. So do all this but 4 times and see what happens. It's important what kind of starting conditions and what end state we have at each iteration. So this probably won't work out of the box, but let's see. Yeah, we're kind of not exactly there, so we don't need this section anymore. Let's see, is that going to be any better? I'm just doing it somewhat by trial and error. Okay, I forgot to bring my pen down again, so definitely we need to bring that pen down again so that it actually leaves a trail. Is this a bit too far maybe? I don't know. Let's see. Let's speed it up. Okay, that's kind of getting closer to this. Okay, I think we need to maybe, I don't have the option here to enter a number directly, so I will have to add another move command. Let's see if that does the job. Okay, that's closer. Looks like the angle is wrong as well, so turn right by 90 degrees at the end of this section. Well, kind of getting there. There's a bit more trial and error in this case. So let's not waste more time, but I'll get to the final version here. The final problem is actually a completely free environment where you can create whatever you like using different functionality. So here we have logic functions, we have loops, we have mathematics. So let me just kind of like show you an example of how, let's say, functions will work. So in the course slides I have a couple of examples of code corresponding to this kind of visual representation. So in this case, for example, the function declaration multiply takes two arguments, num1, num2 of type integer, and returns the multiplied value of the two. In this case, this is how we declare that function. It shouldn't be called square, it should be called multiply. But actually, let me set it up from scratch. So I'm going to delete this. Go to functions. Okay, so this is a function block, and here clicking this cog lets me specify inputs. So I can add two inputs to it. I can change their names to maybe A and B. And we want to return a value actually, so I did pick the wrong block. Bad. So this is the version of the function which actually returns a value. So again, inputs. Yeah, call them something A and B. Okay, and that's it for inputs. And we would like to create a variable inside as well. So create a variable result. I think well, let's call it res because I already have a result in there. This is the value that we will return, but first of all we need to initialize it. So assign to it. So we will set it to, and we use a math function. This is a mathematical expression. Select multiply, and we'd like to use our input arguments A and B in this block. Now that we've had our function declaration, we can name the function, so multiply. If you take a look at the, okay, in this case it's maybe not very clear, but this is a function call. So we use this function multiply now with two arguments, A and B, and we print the result. So what would you like to print? Let's say we will just pick two constants, plug them in, okay, and let's see what that does. Okay, something is not working yet. Okay, because we returned the wrong variable. Okay, so this printed out 20. Not a typical example for turtle graphics because we haven't drawn anything, but you know, it's possible using this visual programming as well. Other example here, let's say a while loop, and this is taken from one of the later games, which is the the pond. So here there's a pond tutor, and we have a floating duck, which we can also shoot projectiles, use some mathematics, and then at the end of it, okay, cool. In the last game, we have kind of an arena with three computer controlled characters with some algorithm driving them, and and our duck, our yellow duck, which we can program ourselves. So I'm not going to recreate this from scratch, but feel free to play with this after the class. So for example, this is an example of a simple algorithm that actually wins against all of these ducks in there. So feel free to drag and drop and test if that really works. It uses the existing pond functions such as swim, scan and cannon, but also it uses variables, and it uses a while loop. It has conditional expressions here, so if the enemy distance, so here the scan function, you can find information about these blocks here in documentation. So pond function, for example, scan function. The scan function activates the duck's radar. It returns the range to the nearest opponent in the specified direction, and the angle is independent of the direction of the duck. Sunk opponents are not detected. If there's no opponent in that direction, then infinity is returned. So you work with these blocks and then come up with an algorithm that does something. So in this case, if enemy distance is less than infinity, which means that we detected something, this is basically what this would amount to, we shoot our cannon, and then otherwise we kind of swim in a circle. I think I can actually quickly test it. I'm just going to copy and paste this. The interesting part about this exercise here on Blockly is that you can switch to JavaScript. So you can actually see the blocks representation of your code in JavaScript, which is close enough to C#, or you can even use that in Unity as well. So this is a good way to kind of gain more confidence with, let's say, for loops. So this gives you a warning: if you modify the code, it kind of loses track of the blocks at this stage. Well, too bad. Let's run it and see. Okay, so our duck is now floating in circles, scanning and shooting bullets, and the hostile AI is pretty shitty, so it's not that difficult for the duck to win. We're down to the rook now. If we're lucky, well, right now we're kind of losing, but I think maybe with a small modification this will win every time. So okay, have a play through with Blockly and have a look at the examples I left you. For example, a for loop example, which is relevant to what we did in our city example, is here. Let me try to quickly recreate something. In this movie game, this gives you a XY coordinate system in which you can actually place objects at a specific position in a coordinate system. So this is a bit more relevant to what we normally deal with in our Unity scenes. So let's go with a loop. So let's count from say 20. Oh, where did you get that? But anyway, let me just recreate really quickly what we did for our wall building exercise in case the for loops are still giving you problems sometimes. So you can see that this count with I from 20 to 60 by 1 is actually a direct equivalent of a for loop. Yeah, the interesting thing there is that's pretty amazing, yeah. The interesting thing about Scratch-related projects is, and actually Smalltalk, is that Smalltalk itself is written in Smalltalk. Might be kind of an interesting tidbit if you're interested in the history of computer languages. So in this case, okay, I'm just gonna quickly set up this loop before we're too bored. And movie has this function here, rectangle, width, height. Okay, let's make it maybe small. No, that's okay. I can use the iterators again, like we did in our okay, variables I and j. We need to plug this in by hand. Okay. In case of the movie example, okay, there's by one. Okay. That's kind of a lot of blocks and not really looking that interesting. So let's vary the color a bit. Always kind of an easy way to do more interesting things visually. I'm gonna plug the color in here and just use I and J. So I've changed the color, the red component of the color along the x-axis. What's happening now is that I think in this particular game there's a limit to the number of objects, very nice, that you can plot. 5, let's see. So maybe let's not go overboard with the spacing. I'm just going to change it to 20. 20. So now we have kind of a grid. Yeah, coding grammar is a interesting topic in itself. I mean, it's related to language, but obviously natural language is a slightly different animal. Okay, let me just plug in the last variable there. So let me also change the blue component and see we start having more interesting shapes. In this movie example here, you can also use the time function. So you can change things with time. Let's see here. This is time, which goes from 0 to 100. Okay, so now if I play this example, the green component changes with time. So that was like a quick and dirty example of working with 4 loops in a graphical setup. Because how do we get to the wall exercise? Yeah, very nice. How do we get to the wall exercise from this? Well, we can add a logic statement there. So logic statement, some of you have done it this way. Another logic statement, a bit more complex. Okay. Okay, so if I is equal 20, okay. The problem with the visual languages is that sometimes the tedium of plugging things in is just too time consuming. You can copy and paste blocks, so let's do that to make it a little bit faster. And then I'm gonna copy and paste this as well. Okay. Once you've gotten the handle of whatever concept you're learning using visual programming, it usually turns out to be faster by text a lot of the times. But it may be good for prototyping or doing creative play around. Again, you're using a slightly different mentality, more visual. So for those of you who are just, are just not the type to enjoy looking at a wall of text, this might be an alternative. Yeah, this is, this is your opinion, and for some things yes, for some things no, and I'm actually gonna get to that point now with the second part of the talk by Alan Kay. Let me just, so if I is equal 12, okay, I think that I made a mistake there. I was supposed to do a logic comparison. I'm sorry. So if I is equal to 20, yeah, this is definitely not the easiest way to, or the quickest way to solve that problem, and using text is definitely so not and but or. So if I is equal 20 and if y is equal 20, however, when you actually look at the outline of the text, you can kind of start seeing the code emerge from it. So when you actually switch between the visual and the graphical representation here, you can see that they resemble each other. In this case, in this kind of final pond example, it actually even gives you the parentheses and the semicolons for JavaScript. So if you actually type this through, you should get the same kind of result. So, well, this may be very quick to set up. It does show you the indentations a little bit. You can see what is contained within which block this is, the purpose of indentation encoding. Kind of obvious things, but I think it was still giving at least some of you some trouble decoding the complexity. So we do all this if this condition is true, J. So we have kind of a half of our wall now. We need to extend it even further. So another logic. In this case, we copy this, Control C, Control E, stick it in there, stick it in there. There you go, and change it to 80 now. Okay, or okay, so this is the city walls again. Let's change the. Okay, so see, it wasn't so hard. Play around with this, and I think this should actually help you with setting up different creative coding variations of for loops to begin with. I think this is already enough to start building variants of your city for the final project. So you can, for example, have a city that is composed of an inner ring of buildings and an outer ring of buildings. Maybe you can think of how to create a spiral, but actually this kind of brings me to the second part of the talk. So let's do that. I'm gonna get the sound going again. Let me copy the link for you. And this should be quite interesting, actually, and we'll work through this. It is talking directly about the Turtle graphics, referencing Turtle graphics language. So.
Now, these ideas work beautifully for music, and they also apply in cognitive areas very strongly. Here's an example of...
So this is a kind of a mechanical version of the logo turtle.
Take the logo turtle and write a program to draw a circle. And we'll do it with 3 ages of people, a 5-year-old, a 10-year-old, and a 15-year-old, as representatives from these 3 mentality dominant areas: the body, the visual, and the symbolic. Now, the way you get a 5-year-old to do a picture, to do a circle, is something that Seymour Papert learned long ago, and that is you tell the 5-year-old, close your eyes and make a circle with your body. After they've gone part way around, you say, well, what were you doing? And the 5-year-old says, well, I was going a little and turning a little over and over again. When you type that into Logo, you get a perfect circle. And that's because the 5-year-old knows differential equations. Because the circle is a particularly simple thing in differential geometry, which was only discovered about 150 years ago by Carl Gauss. So a circle is that thing that has constant curvature, so the change in curvature is 0. And the child's body mentality doing mentality understands that kind of geometry. So the 5-year-old comes up with a very simple program that produces an elegant circle. The 10-year-old has a harder time because the 10-year-old is visual and really wants to look at things. He doesn't want to do things with his body so much anymore. And so he wants to draw circles with a compass. And after a while, he'll see that by drawing lots of circles, he'll see that the main thing about drawing circles with a compass is that the points on the rim are always the same distance from the center. So his turtle program picks the pen up, starting in the center, jumps out to the rim, goes 100 there, puts the pen down, makes a mark, picks the pen up, backs to the center, turns 1 degree, and does that over and over again. So it's chugga 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 chugga, and you get a perfect circle. Much harder way of doing it, but still a good circle. And of course, I wouldn't be telling this story if the 15-year-old were able to get a circle at all, because like most adults, he's in the facts and logic stage, and he knows the most horrible fact thought up by the mind of man, which is x squared plus y squared equals r squared. A very bad coordinate system, and even if it were a good coordinate system, it has very little operational significance. So here we see an example of just concentrating on different mentalities in people's skulls, getting vastly different results in doing the program, and surprisingly, the age levels that are supposed to do less well actually do better. And this led to a slogan I made up, which is that point of view is worth 80 IQ points. So in other words, if you're in 60 BC in Rome trying to multiply two numbers together, you had to be a genius to be able to remember all the partial products that Roman numerals generated. If you're in 1300 AD wondering where Mars is going to go, you had to be a genius to be able to figure out all of the Ptolemaic epicycles. So it's not logic that is powerful. Logic is actually a weak method because it depends on fragile chains of inference. And people have used logic throughout history, but mostly in inappropriate contexts. There's nothing illogical about the way the alchemists or the Babylonians did things. It was that they were in a context in which their logic couldn't do much. So this notion that the context is powerful, and if you want to be able to be good at solving problems and acting much smarter than you are, then you have to find a context that is going to do most of the thinking for you. Most computer scientists know this because it goes under another heading called choose the appropriate data structure before you start tinkering around with the algorithm. Do the right data structure, you will have most of the result computed almost automatically as part of its inherent structure. And all that reminds me of Edward de Bono's famous comment about American business. I think it probably applies to American universities also. He said the problem...
Okay, so that kind of wraps up the Alan Kay part of our lecture. So the interesting bit to take out from that is that your mental framework for solving a problem might be the biggest problem to begin with. So sometimes solving a problem visually might be a better way than solving it symbolically. Sometimes thinking in terms of movement and using your body might be a better way. So in this case, this was referring to the 3 developmental stages where a child is generally thinking in terms of simple movements and body coordination. So funny enough, it happens that our body does things like advanced calculus, just internally, biologically. We are in our everyday life working with forces, and we actually, our body knows how to calculate curvatures for us to be able to pick up a coffee cup from a table and integrate forces. Later on, when the child is at say age 10, it would be more visually oriented. It's at the stage where this mentality is dominant. So this would be attempting to draw the circle by realizing that it's a constant distance from the center. And then later on we start overcomplicating things with symbolic representations and coordinate systems, and we end up not being able to do it very easily. I'm just going to take a couple of minutes to just run through those turtle examples so that we can actually prove it. So let's say we're age 5 and we're told, okay, draw a circle. So what do you actually do when you draw a circle? Let's make let's make a 360 loop to begin with. Let's just move the turtle forward. Very simple. So move the turtle forward by I cannot use a. Okay, let's say by 20, and then move the turtle. Okay, that's because sorry. Just a simple iteration there. Okay, delete that. Okay, here we're just gonna move it by 1 step, and then turn in one direction by 1 degree. So just do a very simple. Okay, I'm gonna speed this up and run it, and voila, we have a circle. So effectively, like, we don't have a control over the radius other than by changing this distance and changing this turning angle. So in some ways it would be a better solution, like it's definitely simpler, but in some ways it might give us less control. Let's move to a later stage of visual, a more visual approach where we're dealing with visual patterns and visual cognition. Again, let's do a loop, repeat it 360 times. Let's do it every degree. Pen up first, so we're at the center. Then we move forward by whatever our radius is. Let's say 100. Pen down. We have to draw a small little line, so unfortunately this doesn't let us drop a little dot. The turtle has to move to leave a trace, so we just move by 1. And then we lift the pen up again, and we have to come back to the beginning, so move backward by 101 so that we end up in the same spot we started with. And then at the end of this, we're just going to turn slightly again by 1 degree, and this should do the job for us in a different way. In some ways maybe this would be a more flexible solution, because now we can control the radius more easily. So again, slightly different approach, different thinking, same result. And then the third approach would be, okay, to use mathematics for it. Now using turtle, it would be very complex, but we can actually cheat a little bit and use this coordinate based game here. How would we go around that? Well, really quickly, let's look at those math functions, and we have a sine function and we have a cosine function. So if you still remember your trig, we can actually do this. We can solve this problem like this. We can just go for another loop. Count with k from 1 to 360 by 1, and we drop a little small, let's say a small circle, radius 1, and we use our input variable k as an input to our sine. Okay, that gives us a very small circle, because this is only going to go from 0 to 1. So we need to do 2 things. We need to first shift the whole thing to the center of our coordinate system, so something like we had to do for city grid problem. So shifted by how much? By 50, right? Okay, so this will place us in the center. Okay, we're in the center, but we still have a little bit of a problem. Okay, sine, cosine. And we need to multiply the result, so another math function there. Multiply this sine by whatever radius we need to have, so let's say 40. Okay. And same for the cosine. Oh. No. The only problem here is that apparently this game only has a limited number of objects it can display, so I need to create a bit of a spacing. And now there's our circle, and we've used math functions. Just to kind of like really quickly, what else we can do with this? Obviously, we can parameterize this, so we can create an input, call it radius. Cool. Stick all this code inside the function, and now we have a function which we can call circle. Same thinking you would actually do in writing the code, but perhaps it's easier and more accessible to like start with this kind of concepts. Once you get used to being a bit more creative coding using text, it will become second nature. But if this might help you get a bit more confident with experimentation, then I think it's worth maybe using this or Scratch. Let's do another loop just to make a couple of circles there, just to make things a bit more interesting, and call our function circle with radius. Okay, let's use a expression. Variable is m. This is our iterator. Multiply this by, let's say, 5. Okay, and I'm just going to change this. 1 to 5. Okay, with radius, and I haven't actually used my radius in the function, and I should have. Okay. So here in this multiplication, okay, so I have a couple of circles now. Okay, got 5 minutes left, so feel free to look through the other examples of graphical based environments. So Alice is a 3D oriented, almost you can call it a game programming, a game engine. Scratch, some of you already mentioned, a little bit more 2D oriented, and perhaps a little bit more like the whole everything around it just screams kindergarten, so I don't know, maybe that would be off-putting. Squeak, and then there's these little things which I just won't have time to get into, but this actually supports C#, so you can work with exactly the same syntax structure that you need to use with Unity. Another one is Code Wars, which also has a wide selection of languages. So these have slightly more complex programming problems to solve. Check them out, they're worthwhile. I think this one perhaps is a bit more useful. This one gets very difficult quite fast, so it basically asks you to solve like a more abstract programming problems to begin with. Before you go, I have a little challenge which is going to be worth 10% of the course grade, which is the Turtle Challenge. You can find the description in the slides for this lecture, so you can just type it down. Any questions about this? Have a quick look. Oh, sorry. I meant 10. There we go. Fixed.
So small optional thing is what 10% of
I changed my mind. It's a homework. Thanks for clarifying. Yeah, I yeah. So I'd like you to go through this. What I'd recommend to do is actually go through first all the turtle challenges. So there's 9 of them. Sorry. Just to make sure everybody's on the same page in terms of like using basic programming structures. Go through this, and level 10 now allows you to be more freehand with your turtle graphics. When you're done, save a link and send it to me via email. So this link will be persistent, so you can send that to me and I can check out what you've done. There's a gallery of already existing graphics. Well, try to try to be a little ambitious and come up with something that's actually nice visually. Another thing is I want you to use loops, functions, math functions, and some logic operators, and have something that looks interesting. So send me the link before next week's lecture, please. And then once you've gone through that, I think you'll find that working with the city blocks and creating something interesting there will be a little bit more intuitive for you. So 10% course grade, turtle graphics. Make it representative or make it abstract. There are some examples there of, for example, recursion. Let me see, this cherry blossom example has a function which calls itself. So it's a little bit like our tower building scenario, whereby having a function call itself, you're able to come up with fractals complexity. So this, if the recursion idea was still a little bit tough to wrap your head around, this might help you. There's another example, I think, there in the gallery for. You don't need to submit to the gallery as long as you generate the link and send it to me before next class. You can get 10 points for that, or 10%. Let me find another Practo. I'm pretty sure there was an recursion tree. That's a simpler one that might be a little bit... okay. Kind of similar idea like in our tower building. By tweaking those functions, you'd be able to come up with very different looking trees. Okay, so that's it for today. Thanks very much, and see you next week, and we'll be talking about animation. Bye bye.